Alright, so let's go through the trial of trial H1 physics from 2007. So we are given a figure, right? And this figure is a pure parallel circuit. So we have 3 resistor, R, 2R and 4R. So we have another supply E of EMF E, right? And negligible internal resistance. So the first part we are asked to define what is the EMF. Okay, so this one is simple. It's just the amount of non-electrical energy converted to electrical energy to drive a unit charge around a complete circuit. Okay, let's move on to part 2. Calculate the total resistance of the circuit in terms of R. So you can see that it's actually a pure parallel. So just use your normal, formula. So 1 over total resistance equal to 1 over R plus 1 over 2R plus 1 over 4R. Of course, eventually you add up, should give you 7 over 4R. But don't forget to flip it. So you flip it, right? So the total resistance of the circuit is 4R over 7. Or you can also put as such 4 over 7R. So this will be the total resistance in terms of R. Okay, let's move on to the part 2. Okay, part 2, what is the current from the supply in terms of E and R? So if you redraw the circuit, right, you recombine everything. So this is just a pure normal circuit. So EMF, then the total resistance is 4 over 7R, right? So you simply just use R equal to V over I. So where my V is the EMF and my R is the total resistance, you do a bit of manipulation, your total current that's flowing in the circuit, right, will be 7E over 4R. Okay, let's move on to the part D, the next part. So the next part is a new part of the question. So you can see that, I have a EMF again, I have a current flowing, and of course there's R1, R2, but it's connected in series. Okay, the next part will ask, we are asked to show that the voltmeter reading V is given by this relation. So it's V equal to R2 over R1 plus R2 bracket E. Okay, let's see how do we actually show it. Okay, first we combine the two combine the two resistance, meaning you'll get R1 plus R2. So this will be the total resistance. Okay, next you simply find your I, your current, right, in terms of your E and your R1, R2. Means the R is right here and the V is the EMF of the circuit. So you do a bit of manipulation. Your total current that's flowing in the circuit is about E over R1 plus R2. So next thing is we are asked to find what is the voltmeter reading right here. Meaning we are interested in this part. Okay, so we must understand one thing is that the current that's flowing through R2 is actually this thing right here, this expression right here. And we are given R2 as well. So I can simply just use another R equal to V over I. So means I want to find V equal to RI. So my R is your R2, your I, right? I will be the current that's flowing in the R2. So it's E over R1 plus R2. So of course eventually you should be able to get something like this. R2 over R1 plus R2 bracket E. So that will be the PD across your R2, which is the same, right? So you can see, right, R2 over R1 plus R2 bracket E. So R2 over R1 plus R2 bracket E. Right, so that's the 4 marks. Okay, let's move on to the next part. So a new circuit as well. So we have a EMF again. So this is a thermistor. This is a 100 ohms resistor with a voltmeter connected in parallel across it. So they ask, describe and explain how the voltmeter reading changes, meaning the PD across the 100 ohm resistor, right? How does it change as the temperature of the thermistor is increased? Okay, so 3 marks, a very standard way of answering. So first, as temperature increases, the resistance of the thermistor decreases. So why the resistance of the thermistor decreases? This one don't need to give them, unless they explicitly ask for it. Okay, second point, as R is directly proportional to V, means that as your R decrease, your V will decrease as well. So the PD across your thermistor will decrease. So of course at the end of the point, right, by your potential divider principle, your potential difference across the 100 ohm resistor will increase. So that is how we actually deal with this question.